hacer una pequeña introducción y luego os voy a hacer un ejemplo. Well, I'm going to switch to English now, otherwise she's looking at me like, okay, I don't know what she's talking about me. So now we have Willem Hendriks, and he's going to do a short intro to this, to his experience, and then he will do a demo on deep learning, TensorFlow, with the platform that we've got on the cloud that you can also try for free. We will make available the material so that you can try at home if you want to. So it's like a little lab that we thought it was going to be a little bit challenging to do it here because we weren't sure if we were going to have enough Wi-Fi coverage. So we're going to give you this lab and you can try it at home later. So Willem, please. Yeah.
Hello everybody. I have a little fight first with the microphone. So my name is Willem Hendriks, and as you can see, I love Python. And I thought today there are a lot of Python lovers here, right? Is that correct? Oh, this is there? Also here? Oh, almost, yeah, everybody. Good, good, good. Oh, I saw one doubting. That's all right, maybe at the end. So I work for IBM. I do data science projects, and sometimes I'm invited for the meetup, and that's always fun because then I can do something, yeah, a nice example. And for tonight, I also prepared an example for you. I hope you like it. And this is a little toy example involving deep learning and Python and TensorFlow. So I put it all together and made an example about Python, about you, about people who love Python. And this is my experience. And actually my goal is that you lose a little bit fear and try it yourself. Because when I heard about TensorFlow, I was interested. And I thought it was very complicated, but you just have to start. And I guess that's all you need to do, right? You just need to find a point to start. And in the Netherlands, I also have a meetup group. And oh yeah, on the right, this is how I feel about it. I have no idea what I'm doing, but it's awesome. Sometimes it just works. But fortunately, that's good. If your network works and you have no idea why, it doesn't matter. It just works, and you have a good performance. So it's nobody really understands what's going on in all those layers. It just happened to work. And in the Netherlands, my first experience was with coffee and coding. It's in a meetup, but it's not really a meetup like here, that there's a presenter telling something. It's just coffee and coding, and no presenter, no format, nothing. So what we need is a place with power and good coffee. We found it, and we were, I think, with 6 or 7. Those are a few on the picture that were willing to go on the picture. And what we did is we started with TensorFlow, and nobody has touched it yet, and that's how we all learned it. And I thought it was great because after everybody liked it, you see everybody smiling, and we helped each other. This guy knew a lot about all networks. He done projects trying to predict financial models with network. He knew a lot, and he helped everybody. And I thought I talked about Victoria with this, and if you like this setup, you want to start, you are excited today to start with TensorFlow, and you'd like to do this too, coffee and coding, then you teach yourself. Let us know on the paper or on the Meetup page. Then we do a coffee and coding in Spain, and that's it. Then you can help each other a little bit. It's always better to try with somebody else, right? It's more fun, and you learn a little bit faster, because if you we did all the intro examples, we got stuck, and then help each other. not everybody was a programmer. He is a friend of mine, and he was just laughing the whole day about all the terms we said, tensor and the weights, and he was and he just kept the whole night, and thought it was fun what we were doing. So, having said, I'm not an expert on neural networks. This was about a year ago. Then I did testing, and I played with it, created examples, but I did cool projects like the previous speaker. None of it went into production or a product. All my experience is just from toying around, and that's it. So I already know that everybody loves Python here. That's a lot of people, and we now all know what a neural network is. And backpropagation. Who has heard of this term? Oh, that's a lot. Oh wow. So everybody is already much more expert than I am. And there's convolutional neural networks. Who has heard of it? Yes. All right. Okay. So this is great mix for the coffee and coding, because if there's a mix from the hands and no hands, then everybody can learn. And who here likes to start with deep learning and start with TensorFlow and like to like me have little experience and want to know a little bit more about it. So this is, wow, oh, that's enough for the coffee and coding. Everybody, great. Oh, there's at least one expert. Yeah. Good. Coffee and coding. So last time I was here, it was, I think, about I did something with the weather and the soccer prediction, and I talked with somebody from the Python community. I don't know if he's here today. Luis? Yeah, me. Ah, yes, with you. Yeah, and I talked about how we love Python and the community around it, and then the word Pythonic, and people who like Python know it. Sometimes on Stack Overflow you see somebody with an answer, and then somebody overrule him. Yeah, this is more Pythonic, and then he recreates the code, and maybe it's slower, but everybody likes the more Pythonic. So I like this, that languages have their subculture, and I was wondering, could we create in Python a neural network that detects how Pythonic your face is? And see, and the most Pythonic face, though I not really know what it is, but I found this guy and I thought, yeah, that's he's not, he looked very Pythonic to me. And this idea came from something that a colleague of me did with Watson. There's a hat from Harry Potter, the sorcery hat, and probably you all saw the movie, and it tells you Slytherin, it tells you which school you are. And with Watson API, he did the same. He used the speech to text to convert what the child say into text. The text went into personality insights. That's the Watson that tells what type of person you are. Then based on the personality insight, if you're very extrovert, you go into the school where all the naughty kids are, and if you're very shy, you go in the one where Harry Potter was in. And then there's another text-to-speech that the head said, you're in Slytherin, and well, it detects what kind of person you are. So I want to do the same with Python. I'm not even sure if it's possible at all. I'm not so sure, and of course, it will never be 99% accurate, but I want to try to outperform a dice or a monkey, just random, you know? So if the network can detect a little bit more, then I'm already happy. Who thinks this is possible to see by the face what type of programmer you are? Anybody? Oh, yes, all right, thank you. Oh, two, thank you. So let's try it. This is what I tried. So looking back at the picture, I can already see one guy with glasses and me, so glasses might be a hint. A lot of unshaven guys. He was not really Python guy, so he was the only one that was shaven. I don't know if I shaved that day, but I see quite some beards here, so it might be a hint for the network. And slim. So I see a lot of slim, unshaven people here. So that could be something Pythonic. Maybe the network could see it. So my goal was to take the most easy TensorFlow example I could find. That was about the MNIST. It's a little bit the hello world for can I say that? The hello world for yes, the hello world for teaching networks. And what I wanted to do is with minimal changes, trying to let it learn if a person is Pythonic or not. So what kind of language does he like to write code? And of course, the project file is okay. I just wanted to see if it's possible, and it could be a nice thing maybe for the coffee and coding to try to improve the project. I thought it should be easy, so if I take something, if I take the MNIST example, there's a lot of documentation about the MNIST, so that then you can use that documentation and see how the minimal changes you got for this, and then, well, yeah, have a little fun with networks. And the first thing that I had to do, of course, is find data, and I used first about the MNIST. There's one example that's very easy. It's not really deep learning. It's one layer, and we just learned that the more layers, and there's one that is with multiple layers, and it's all on the same test set. So there are two examples. I just did the one, and the second, well, we maybe at coffee and coding. So I went to the LinkedIn. I got pictures. I typed Python, look for people with Python skills, and everybody with the picture, right-click save, right-click save, right-click save, until my hand got tired. Then I switched to another language. I did Python, C, yeah, this is a little C++, Java, ASP.NET, and I just get some picture. But I already have a fail guarantee, because for each language I just got 50%. This is not enough to train a network, because these neural networks you need to flow a lot of data in to get a little bit training. So if it worked, it would just be luck, would be my guess, because this is but still, let's see if it worked. So one thing I should do to improve, and maybe if anybody has some better data set or access, let me know, because I would love more data about this. If you have an idea how to get Python faces and non-Python pro. Oh, that would help. That would help. Well, no, let's not do it. But that would help. Yes. So then I converted the images, and in the example, it is a NumPy arrays. So that I got JPEGs. It needed to be NumPy arrays. So well, it's a very friendly script. Just I think the most difficult one was to install this library, because it had some dependencies, and I transferred them to NumPy arrays, and that was the exact same format from the MNIST. So this is, I just needed to change the MNIST data to the Pythonic people data, and then it would train on, instead of trying to guess the digits, try to guess the programming language. Then I create some data feeder. This is just from the files that have all the arrays of the people converted into NumPy arrays, and this little class will give a batch of data, and the size of the batch you can give as an argument to the function. And then I modified it, and I tried it, and it worked. But the test is only me, so I only tested myself. And I'm happy that I look Pythonic, of my own Pythonic detector, but I was not really satisfied, because normally you want something to work, but actually I wanted it to fail, because I cannot, this must be a lucky guess. So I thought, let's take another picture of me, and I tried to look a little bit like him, and see if then the picture would, yeah, it worked again. So maybe this is the Pythonic look with something in your mouth, and then but it worked again. That this shouldn't work. So I'm actually a little bit angry that the Pythonic detector worked on my small test set. So this is something I want to improve with more data. Then I have the luxury to make a proper test and training set. With 50 images is so small that I wanted to use them all for training, which is something that is not good, because normally you need to make a fair selection. So I put this code on GitHub. That is the URL, and feel free to help me, please, if you have any ideas, because I think it would be cool to really do this actually because I think it would be a nice achievement of neural networks to outperform a monkey to see what type of programmer you are. And I know that one person is with me about that it's possible, so I think it might be possible. The C programmers, sometimes, of course, I'm biased. I thought to see more gray-haired people with C and Java, and the ASP.NET maybe looked more shaven, tie looked more professional. So it could be that it's possible. So what I want to do is get more data, and I want to modify my code to work on the second example of MNIST, and then that is actual deep learning, and then 50 is really too small, so that I really need to get more data, and maybe try to make this into a web application, so that you can go into the webcam and have some Pythonic detector, some rate between 0 and 100 to see how Pythonic you look that day. Yeah, for the people that want to get started, I want to show the data science experience. That is a online platform to collaborate, like Victoria said, we support a lot of open source tools like TensorFlow, and I'd like to show now a little bit how to redo the MNIST example on the data science experience. So if you do the coffee and coding, only thing you need to do is bring a laptop and sign up for this, and then you have an environment which is all set up. Of course, you can also do it all on your machine. Then you have to download a Docker file or something. It's all up to you. But I like to show how it will go with data science experience. This is IBM's data science experience. And here are all my projects. So a project is just an entity of some model or some project with data, models connected to it, maybe articles. And it helps if you want to collaborate on something with more people, that you have all the data in place. And here I have some notebook of the TensorFlow example of MNIST. And this is the example that is just, that is the one that we did this day on the coffee and coding. So I think I spent probably around 15 minutes to get my TensorFlow up and running. I needed to download it and get it into a notebook, get my environment. So this I could save if I did we didn't have the data science experience back then, but I could save those minutes by just going to the website. And here you see a notebook. A notebook is a mix between code and documentation. It's the first time that programmers actually go to document their code because it's so easy and looks nice. I think that's why it's so popular. And I want to show you how to create the MNIST example with the data science experience. Let's say I didn't have this notebook, then I can add a notebook. And on the GitHub, I have the code I used to train the network, to see how Pythonic you are. And I also have made a notebook with the TensorFlow example. And this is the URL of the raw code. And I can type, create a new notebook. Create new notebook. And that's it. Now I have I have TensorFlow almost installed. I need to execute the first cell. Where is it? Here, pip install TensorFlow. And now it's, because it's already installed on my machine, but if you just signed up for the data science experience, you might not have it installed yet. And after this, you can start. And you can start doing the demo that is on the TensorFlow website, this one. And after you've done it, you're already on the knowledge level of me and can try to improve the projects to see how Pythonic a guy is, or girl. Let me see, it was this one. So that's it. I also put it in my presentation so you can read it later. For learning material, Emma already said some great. I also like to share my experience. The online course I did a few, some I finished, some not, but the one that I really remembered and got most knowledge from is the machine learning course from Coursera. And everybody who has started it, I only hear people saying good things about this course. It's a little difficult because it's quite applied, and sometimes mathematical concept of linear algebra, if you're not familiar with it, it may feel a little bit, whoa, it's a little bit rushy sometimes. And then you see a formula on the screen and you don't understand it. But I'm very relieved that Andrew Ng, the tutor in this course, sometimes says, yeah, I actually also don't know what's going on in this particular thing when he trained the network. So okay, good. So you don't need to know all the bits and details. And that's again from the beginning. If the network works, then it works, and there's not a human on Earth that can explain why a certain weight is all the weights are certain values. Because if we could explain, then we could make the network and not need to train it. So this is a really nice course. And there's also, I haven't found a real good book yet about it. A book that will go from start to end. If somebody had, please tell me. But there was, somebody, what is the good book? I saw a hand about a good book. No? Oh, it was not a hand. So nobody knows a good Bible. But these are two links for one of them. I don't know which one. No, it's the other one. This book is now free because it is under, I think it's being proposed to go for press, and at this moment it's a free book, and I haven't read it all. I more or less scanned it and took some things about when I wanted to learn, but at least it is well written. It's not bullshit, or it's really good content that it's correct. It's but I'm not sure how it would take me if I went from zero to be able to create my own network from scratch. So maybe if I had to do a recommendation, I would start with the Coursera course, because it's nice to see somebody talking and have some exercises, and then see if the book will help you to get you on the better level. So who think I was lucky about the network, and who thinks it is actually already performing? It's probably luck, right? Yes, yes, I think so. But again, if you want to help improve, please do, because I'm going to continue anyway. So the GitHub is there, and I'm not afraid to try a little bit, to try some weird ideas, and maybe if it turns out to be actually working, we can present it again and tell more people about this. That was my thing I like to share with you today. Pregunta, right? Yes?
Great talk, Willem. I'm glad that you took the challenge of making this neural network.
Yes.
My question is, imagine that in fact you achieve a precision of 80% or 90%, whatever, then would you be able to see what features are the neural network is taking to classify the problems?
Okay.
Such as, imagine that the neural network says, okay, if this guy has glasses and long hair, then he's a C++ guy,
well,
and otherwise it's not. Are you able to learn that information from the neural network or not?
Well, if it's a lot of layers and just the features are just the raw pixels, then I couldn't, because I would just see weights. Maybe sometimes what they do is they make images of the layers themselves, but that are more those weird psychological ink pictures to me. I cannot make any sense of them, and I haven't heard somebody who could make more sense of it. But if anybody is here that has
in Geoffrey Hinton's course, in 14th lecture, he tells exactly the same thing. Especially when it comes to recurrent neural networks, it's impossible to detect what's happening in one hidden layer, and it's not meaningful. Two neighboring models actually might have totally different values in hidden layers. And he compares the output vectors testing in a set of test cases, and he compares directly in a TSNE. Maybe everybody is not knowing it, but TSNE to show multidimensionally how each model is sitting with respect to each other. So this is a way to compare to neural networks model.
So it's difficult.
Yeah.
You can compare the outputs, but what might be, sometimes you have those multi-layered, multi-stage processes. So if we, by this small NS5 example, we know that glasses could be a thing, that we might, we see some glasses here, that could be a thing. We might be able to create a separate network to detect glasses and use that as extra information, and then the beard, and who knows, then we can get information out of that. So that's how detection of images sometimes go. So.
Any additional questions? So maybe we can do the survey here. Who would be interested in coffee and coding with Willem?
Oh, good. I'm not sure if I can be here, but I would try to, of course. I would come to Madrid for some coffee. Oh, thank you. Yeah.
In the Python Madrid group, we already have a big weekly study group where people gather and learn coding and stuff like that. So if anybody's interested, they can just
you can collaborate and make it one big, a lot of coffee, a lot of coding.
Yeah. We don't serve coffee yet, but it's a good idea.
Oh yeah. Oh, you don't serve coffee and you're coding?
No, it's coding and coding.
Okay.
So then Willem, thank you. And you have seen that his code is available in GitHub, so you can contribute as he was explaining. And then if you also want an easy environment to start with, and you don't want to download everything and start from scratch, you can go to the IBMdatascience.com, and there you can try for free. We give you 2 Spark executors for free, 5 gigabytes of object storage. It's not to do the asteroids classification. I mean, it's a small, well, relatively small, but you can start with that, and it's as simple as just typing the URL into the notebook when you create it, and you will get just immediately all the hard work Willem has been doing for the last 2 weeks.
Oh.
Immediately they are available for you to be used. Thank you. Okay, switch to Spanish.
Sure.
Vamos a pasar ahora. Gracias. Bueno, ahora tenemos las pizzas, bueno, la comida, no sé al final si hay pizzas o qué es lo que hay, pero bueno, tenemos la comida aquí en la sala de al lado. Como somos más gente de la que normalmente tenemos, no sé si cabremos todos, pero bueno, podéis entrar, coger lo que queráis y podéis pasar a esta zona de aquí de exhibición, que hay también mesas, un poco para que estéis cómodos. Además que aquí hace tanto calor que, bueno, así estáis un poquito más... Muchas gracias.